So yesterday you learned about polynomials, and you may or may not be done with assignment number 39. It's okay. You can finish that at your leisure. By this point, you should know how to put things in standard form, and then you should know how to identify things. Just again, it's not a super big deal. It just makes us feel less dumb when we talk to each other. So, if I say quadratic trinomial, then you don't just stare at me like, what? Then you know exactly what I'm talking about. So yesterday's lesson is really just kind of a get to know you sort of thing. Today we learn how to add and subtract polynomials. After this will come multiplication. I don't think we should do division of polynomials in Algebra 1. I'm sometimes even a little bit reticent to do it in Algebra 2. So we will for sure today knock out plus and minus. Next week early, we'll knock out the times. But division is something that we reserve for a little bit. It's a little bit more upper level. So if it's something you're interested in learning, which I know might sound weird, but some people really like math. And so I could certainly show you how to do it. It's just a chore. It's like a big, long division process. Do you remember the old division that you used to do back in grade school?
Yeah.
Where you had to write the division sign and then you're like, okay, how many times does 4 go into 13? And then you put that number there and then you subtract and carry down it's like that, but a high school version with X's and stuff. So like I said, if you're interested at some point, I'd be happy to teach you. So adding and subtracting polynomials is pretty simple. So here are the 4 types of problems you're going to see in your assignment. If you'd care for any more examples of any of these, you got to just speak up and I'll help you. So this is what it looks like. The delta will say something like perform the operation or something like that. That just means do the math. And so here's an example of what addition can look like. So that is an example of well, here, let's see if you learned something yesterday. Classify this first one for me. Tell me what it is. What is 3x squared minus 4x plus 5, Jeff?
Um, it's a quadratic or yeah,
You're fine.
quadratic triangle.
Nailed it. So if I take a quadratic trinomial and I add to it, what's the other one?
Oh, polynomial.
Quadratic binomial. Very good, Nash. So if I take a quadratic trinomial and I add it to a quadratic binomial, I'm going to get some other sort of, presumably another quadratic. The only way it wouldn't be a quadratic is if the x squared terms happen to cancel out when I show you how to do this, but it's really simple what we're about to learn. Really, what adding and subtracting polynomials boils down to is combining like terms. And so the first thing we always want to do is we want to take off the parentheses and get all the like terms or the terms out in the open. So I'm going to take the first parentheses, just write off 3x squared minus 4x plus 5. And as far as the second parentheses are concerned, there is a plus 1 in front, you can see. But what happens when you distribute 1 positive? Right. So these parentheses can just come right off free of charge. So this can go just straight to minus 6x squared and minus 11. Okay. So that's always going to be step 1 with an addition or subtraction is let's eliminate the parentheses. Get everybody out in the open so that everybody's free to move about the cabin. And now all we're going to do is we're going to go in standard form order. So that means we're going to go and find all of our terms first that have the highest exponents on the variables. And so when I teach this, I do a lot of drawing of circles. So I'm going to take not circles, but just dumb shapes. So if I take this red and this red, I'm going to combine those like terms. Notice when I drew my little shape that I put the minus in the shape. That's really important because without that, you might say something dumb like it's 9, right? Which of course it's not because it's 3 minus 6 we can now see. So what happens if you combine the two red ones? Good job. And I was hoping you would say squared to the power of 2, whatever, because the exponents don't change. We just change the number of them that we have. So if you have 3x squareds and you take away 6x squareds, now you have negative 3x squareds. And we just keep descending down the line and we combine the like terms as we go. So if I were to draw a shape around this one, who does he go with? Nobody. He's got no like terms. So we just put minus 4x in the answer like this. And then finally, I have my last two terms. And what are these called from yesterday again? These numbers without variables? Nice job. They're constants. So usually adding the constants together will be the last step. And what's 5 minus 11? Yeah, so that's how you add a couple of polynomials together. At the end of the day, it really just boils down to can you combine like terms? Now, if you sit through that and then say, okay, now I'm going to go to sleep because this is dumb, I just want you to be aware that subtraction gets missed 1,000 times as often, and I'll show you exactly why. And when I show you why, you'll just have a choice to make. Your choice will be, do I want to show my work? Do I trust this guy? Or do I want to prove to him that I don't need to show my work? I will just tell you on behalf of the thousands of kids that came before you, subtraction is dangerous, okay? It's not hard. It's just we get all high and mighty and think that this is easy. So here comes a subtraction problem. Sorry, that plus sign is so down low. I don't know what happened there. So the same step one applies. Like I told you in the last problem, step one is to eliminate parentheses. Um, these first parentheses here, there's really nothing in front of them. I mean, there's like an invisible number one, but those ones can just pop right off free of charge. Like there's nothing to worry about there. So when I'm getting the parentheses gone, I could just copy down the negative 4x cubed minus 2x squared plus 3x. And this is where you can I say this isn't like a challenge. You can trust me or not trust me. I care about you. I've said that a lot this year because I do. I really value your success. And in order to always make sure you get these right, you should not skip this next step. Give this step some respect because what's in front of the second set of parentheses? A negative one. And that needs to be given full respect. I teach all different levels throughout the day. And no matter what level I'm teaching, distribution of a negative gets missed at all ages. It just boils down to how much trust are you willing to put in me? How much time are you willing to spend? How much work are you willing to show? So this time I'm not just going to take the parentheses off like just brain dead, just kind of sleep through it. I got to be on my game. What happens here? What do I get?
Negative 2 squared.
Minus 2x squared. What happens here?
Positive 4.
Good. And we sit through this and we think this is easy. And I'm inclined, like it's not hard. It just gets missed. I know it's like we get suckered into assuming, well, this is easy. I don't see how you could miss this. And that's when the trouble starts. -5. And now everyone's free to move about the cabin, and we're right back into that mindset of saying, just combine like terms. Who's the leading, most powerful term?
X squared.
This guy right here says, look at me, I've got the biggest exponent, so I'll go first. But he doesn't have anything, so he just gets copied straight into the answer like this. And then next up, we just scaffold our way down the line. Next up are the x squareds, the quadratic terms, we say.
Negative 4 squared.
Nice job. -4x squared.
X squared.
And then next up are the linear terms. 3x plus 4x makes
7x.
nice. And then, of course, we have our constant, which there's only one of those. So that's the basics. I've got two more examples. Do you have any issues with just the process? Subtraction is addition is a joke. Addition is just combining like terms with parentheses. It is easy. I will straight up tell you, we don't show work on addition because it's easy, easy, easy. Subtraction, you give it respect. Okay. Now, there are some word problems in the assignment, so I'm going to copy them up here because this is what the program will ask you to do. It will say find the sum of, and it'll give you a polynomial. The one I wrote was 11x squared minus 3x minus 10. And this. I mean, is that really a quote unquote word problem? I mean, I don't know. That's kind of a stretch, but it doesn't just say a math problem. You have to know a little bit about words and stuff. So, what is the problem asking me to do?
Find together.
It's asking me to add because I know in mathematics that this word sum means addition. And so this is not the type of problem where I or Chris or Wyatt or anybody needs to show work because it's addition, and addition is a joke. So I don't expect you to show any work on a problem like this. We just know we're being asked to add them together. So which term is going to go first? 11x squared is the most powerful term, so we're going to take it and we're going to place it into our answer. I would normally look and see if it has anyone to go with, but I already did, and it doesn't have anybody. Who's up next?
Negative 3x.
And add those together, and what do you get?
Positive.
Good. So I'm going to put plus 2x. And then who's up next?
Negative.
The constant terms, right? So the minus 10 and the minus 4, the negative 10, the negative 4. So this last one is the hardest of them all. And I this year I learned my lesson. I am putting example number 4 in the lecture today on the recording in your notes because every time this assignment pops up, I've done this a couple of years in a row. I got to go back over this. So here it goes. This is one, unlike the last one, where I'm going to ask you to show work. And the reason is because it's subtraction. And like I said before, we should fear subtraction a little bit more than we fear addition. So how do you think we would set this up? I didn't want you to set the last one up because, like I said, it was addition, it was a joke. How would you set this up to make it look like one of these up here that we did? How would you set it up?
8x squared.
Let me ask you a question. What's the answer if you subtract 3 from 10?
-7.
Nope. Subtract 3 from 10.
7.
It is 7. If you have 10 apples and you eat 3 of them, you have 7 left. How about this one? Let's subtract 1 from 20. What do you get?
-9.
I want you to understand that if you take 1 away from 20, you still have positive 19, don't you? What I'm trying to get you to learn here is don't be so literal about this and think that you're just going to do everything from left to right. You have to outwit this problem and understand what it's asking you to do. When I said to subtract 3 from 10, your brain should have done 10 minus 3. When I said to subtract 1 from 20, your brain should have done 20 minus 1. Do you see how we're flipping them? You have to understand the English language well enough to understand that when they say subtract A from B, you actually do then B minus A. So having said that, let me ask you again, how would you set this problem up? Subtract this from this. What would the setup be?
Subtract -x squared minus 2x plus 5 from 8x squared minus 9x minus 12.
No, don't use my words back. I don't want any words. I want letters and symbols. I'm telling you, I want you to write this as a math problem. I want it to look like this. Can you do that for me? What's it going to say? Jeff?
-x squared minus 2x plus 5 minus x squared, 8x squared plus 9x.
And I'm not going to change signs, Jeff. You're the kind of guy that I know would have no troubles with that, but that's not where I'm going to go. So good job. I picked up what you were putting down. I clearly need to get better at my job because the point I was trying to make is that when someone says subtract A from B, you have to write it as B minus A. I failed when I tried to explain that. Maybe I'll do a few more of those next hour. Do you understand that subtract this from that means you have to do that minus this? So this is the setup. And then since it's minus, we're going to give it full marks. And you notice that Jeff, as he was reading it to me, he was already getting a step ahead and changing these signs. I'm okay if you want to do that. All right, so this, if I take the parentheses off, is going to be negative x squared minus 2x plus 5 minus 8x squared. What's after that?
Positive.
Plus 9x and good job. And then once you survive that step, everyone is now out and free to move about the cabin. The moral of that sort of clumsy story was, again, subtraction, depending on the wording, needs to be done backwards. Okay. So if we combine like terms, how many x squareds do we get?
Negative.
I see negative 9 of
Oh,
those.
yeah.
How many linears do we get x's?
7.
Positive 7. And then, of course, the constants will always go in the back, plus 17. And that is that. It is on Delta Math. You'll see it. It's called assignment number 40. And I'd like you to work on that and get that done. I would just encourage you to do paper or whiteboard or whatever on subtraction. Addition, I'd be surprised if you ever decide to show work, but subtraction should be on paper or whiteboard.